Hey, thank you everyone. Can you hear me? Yeah, great. So, my name is Yishai, I'm the CTO at LinearB, and I'm going to talk about GenAI. Are you using GenAI today? Are you using GenAI to help you write code? Great. On my agenda, we'll start with some results from a survey we ran in the industry to better understand what the engineering leaders are saying and doing with GenAI. So the CTOs, the CEOs, the VPs of engineering, how are they looking at the space? Then I'm going to dive a little deeper into the kind of risks and bottlenecks that GenAI brings into the process of delivering software, and how to use metrics and measurements to understand that journey. So there's a view here for the engineering leaders, but as practitioners, we all should also be thinking, okay, how do I know this is helping me and helping my team? Where is it, maybe blocking or causing issues with my work? And it's also useful to have this mind of how are my executives in my leadership thinking about this? How are they framing the questions? Because eventually you're going to be asking for resources or budgets or tooling or permission. Be aware of the way they're thinking about this. Hold this thought. I'll get back to this later. The bots are coming. Okay, so we start with the GenAI impact report. This is, again, we asked our customers and the industry at large, what are you guys doing? What are companies doing? And how are they thinking about GenAI for coding? This is not about writing or creating GenAI applications. It's about using those LLMs and models and tools in the work of creating code, getting it delivered. And I'm going to talk through 5 key insights from that survey. Let's start with the adoption journey. So almost 3 out of 4 companies are already using GenAI tools in writing code. We were frankly quite surprised by this. We thought the numbers were lower. But almost everyone is already doing it, either fully deployed or trying the waters, but already in play. This is one of the faster adoption rates we've seen for technology at large, and definitely and we're talking with larger enterprises, with mid-enterprises, different kinds of companies. They're all in. And if you look at the typical adoption curves, we're already here, like the late majority. This is very, very fast becoming commonplace, table stakes. Everyone is in it. It's no longer a future. If you think about what are the priorities? Why are companies going and adopting GenAI tools? And I'll use Copilot here as a term because most are using Copilot. You can see these block diagrams. Developer productivity and developer experience are the #1 drivers. That's what different roles, and you see the differences between the C-levels or the directors, which are like managers of managers, or the managers, team leads, managers of development teams, product teams, and so on. You see slight differences in how they think about the problem, but you can see the top 2 are productivity and experience. I think this is not a surprise. The big promise of those GenAI tools of Copilot is you can be more productive. And most developers that we've talked with, and I think you'll not find that a surprise, enjoy using those tools. To some degree, some enjoy and then get disappointed a bit, but helping my developers with their experience, with their feeling of getting things done, and getting more juice, right? Can we do more with less? These are the top drivers. This is a graph that shows, if you go from left to right, this is the maturity of the specific respondent's journey. Either they're not even thinking about it all the way to it's fully deployed. This is part of how we work. And if we look at the 2 key use cases, the gray bars are about GenAI helping me write new code. And you can see as the adoption progresses, that use case is more and more important. We read this as this promise is actually like the technology is making good on the promise. You can see that as companies are further down the adoption journey, this use case is important, and they get the benefit. The other use case, which is in assisting with code reviews, with understanding changes in the code base, that's another thing that GenAI can do pretty well. The trend is the opposite. That's an area where the maturity is not there yet, and when you are only beginning, it may be high on your wish list. When you're fully or further on the journey, you begin to understand that it's not, that use case is not mature enough, at least for now. And the other question we asked was like, how do you go about understanding what to do? Is it helping you? What's the impact on your organization? And we asked about surveys, like ask your developers. We asked about direct measurements, find ways to measure, get metrics. And we also asked about run surveys for your managers, your team leads, your managers. And you can see that surveys are high on the list. That's the gray bars to get started. At the beginning of the journey, that's how most of our respondents tackle the problem. But that goes down as with more mature adoption of GenAI tools in writing code, leaning on metrics becomes more important. And leaning on, like, give me the hard facts. Help me measure, understand what's happening so I can better manage this experiment or new technology. And finally, not surprising, what I wanted to put it here, the top 2 concerns, and again, we map this by the, like, where I am at the journey, is about IP. We know that GenAI carries some risks or perceived risk around IP and security. These are the top 2 reasons of like why not to start or why to tread lightly. These are the top 2 concerns in the industry around this. Take a pause here. We remember that the bots are coming, and I want to talk about the stupid bots and the smart bots. So the stupid bots are the non-Gen AI. They don't have intelligence. They're just simple machines that create PRs. For example, Dependabot. Lots of good engineering happening there, but that's not trying to be an intelligent bot. It's about security, compliance, and other kind of rule-based bots that will create PRs for me. And the smart bots are those Gen AI and LLM-powered bots that are already starting to happen. So Copilot is a way to help me write my code, but there are already companies out there that with bots that create end-to-end pull requests. Like they take a task, they write the code, and then you as a developer can maybe review that and merge it. So we see that progression. And one thing we've seen across the big data set that we have access to, even the stupid bots are already creating a big shift in the shape of how code is getting delivered. For our customers in organizations that use any kind of dependency management bot, like Dependabot or Renovate or Snyk or others, north of 13% of their pull requests are bot created. This is huge. Think about all this code or code changes getting created, not by humans. Most of them are extremely simple, just a patch update. But it's still a pull request. It's on someone's queue. Someone has to walk it through the process of getting merged. And this is, you thought all the work was happening by humans writing code. This is no longer the case, even before the GenAI revolution. So let's talk a little about the risks and the bottlenecks. And these are not specific to GenAI. They're also relevant for those stupid bots, but GenAI takes it a step further. So first thing, quality, right? You have code that's generated by a model. We all know about hallucinations. The model, it feels good, it looks correct, but actually, there's this parameter never exists for this function, or this whole import was invented doesn't really work. And we see, there is some research here, that there is a downward push on quality impacted by the rise of GenAI in the coding process. But also think about the code review. Eventually, you want to review or hopefully get some scrutiny on the code that's getting into your code base. How do you review code that no human wrote, that no one wrote? How do you defend it? Typically, when I'm putting up a pull request, I'm getting comments. I can think about them, I can accept them, I can maybe defend my position. How do you do that when you did not write the code to begin with? So that process of reviewing code has to change in some way. But even worse, think about the pipeline. And pipeline here, I mean the human pipeline, code reviews, decision to merge, all of that, plus the automated pipeline of CI, CD, testing, all of that. Is your current pipeline capable of handling 10x more code? GenAI in that revolution can easily 10x the rate of incoming code. And you're going to get stuck with huge review queues if you don't change something. You can maybe spin up some more machines for CI and CD. In most cases, that's going to work. Maybe you have some resource limitations on how you and where you run your tests. But the human factor, that will definitely not scale, and you cannot spin up more humans to review the code. Nor do you want to trust AI to actually also review the code as a solution. So we talked about the code reviews as a key bottleneck that is getting highlighted by the stupid bots and even more by GenAI work. The CI/CD pipelines. And then task scoping, and if you think about the work that is getting assisted or created by GenAI models, if you're not doing a good job at scoping down work and having, oh, this is a very well-defined small task that I can ask a model to do for me, you're going to run into a lot of problems with the boundaries of the task. And we all know that it's easier for humans to deal with even mentally carving a task or what they need to do from a not so well-defined task. For models, it's going to be more difficult. How do you mitigate this? So you start with software engineering intelligence. That's a keyword or a buzzword for the market that we operate in. This is about measuring and understanding your development process, getting metrics around what works and what doesn't. We talked about CI/CD. If you don't have those pipelines in place, if you want to get ready for that 10x revolution, start by automating your CI. Start by having some CI. And a continuous merge is how we think about the review process and the decision to merge code. So CI typically lives after I've merged, or it's like automated processes for my code. But can we also automate part of the review process? Can we automate part of the merge decision so that not all pull requests have to go through a manual step of someone has to look at the code, make some comments, get an approval, and then click on a merge button? That will not scale with the new influx of code getting created by humans with bots in the mix between. And so to unblock those bottlenecks, you want to think about workflow automation for code reviews, continuous merge. How do we avoid all that human toil just to review code or just to get PRs merged? You want to think about your CI/CD efficiency. Get ready for that 10x, which means thinking about partial CI, selective CI. How do I only run the things that are probably going to fail first so that I fail fast and get some feedback to my developers quickly? And you want to be thinking about your deployment frequency. This is a time to invest in getting higher deployment frequency, getting better at deploying code faster. If you have that muscle in place before, again, the onslaught of all this new code, that is going to be your key to be able to actually get the value from GenAI. Otherwise, you'll have a heap of changes in the code waiting to get deployed or to happen, and you're stuck with your old processes and your slow deployment, you're never going to realize the benefits. You're probably going to get hurt by all this backlog or backed up pipelines. Let's dive into metrics. So looking at how to measure the impact of GenAI on my work. As a development organization, as a dev team, we're looking at 3 types of metrics and 3 questions. First, I want to understand adoption. Are my developers using those tools? To what extent? Is this some islands and some teams? Is this across the board? So just adoption, a simple question, but it's important for executives and leaders to understand, is this technology real for my organization? Second, the impact. What is it doing for me? How is it helping me? Is it reducing time to get things done? And so on. And then the risk. How is that impacting my ability to deliver all those pipeline risks and bottlenecks that we talked about? How do I measure that so I can better protect myself and unclog those bottlenecks? Some examples of adoption metrics. Copilot has a neat new API about org-level adoption. So you can start by looking at actual suggestions and acceptance rates for Copilot. You can look at how many users are using Copilot across the org. That's just an example. I'll show a few more. You look at impact metrics. You want to think about things like your cycle time and how it splits between the different stages. In this view, you're seeing some of our the way we at LinterB measure things, and also our industry benchmarks. So we're basically publishing industry benchmarks for all the metrics that we measure. Cycle time, how long does it take me from my first commit on a branch all the way to deploy in production? That's a way for me to track if using GenAI is helping me or not. If it is helping me drive cycle time down, great. If cycle time is going up, I may have a pipeline issue. And similar for other metrics. And then look at the risk metrics. So you want to look at, are my pull requests getting reviewed? What kind of review are they getting? Is this a real review or a quick 20-second rubber stamp? If you're seeing a spike in very shallow reviews, this may be a problem leading to quality issues. And if that is tied to your GenAI work, then you know that you have an issue. People are not reviewing the GenAI code as they should. I'll use this example to highlight a couple more. In this view, you can see us contrasting the Copilot tagged work. These are PRs that were assisted by Copilot versus all the rest. So I can look at PRs opened as a way to understand adoption. Is adoption of Copilot rising? Is it eventually reaching the 70–80% of my work that's full adoption? Or is it just happening here or there? You can look at review time. I cycled that in, like I marked this in red. Review time for the Copilot PRs is much longer than the baseline. This tells me there's some issue in my human pipeline on getting those PRs reviewed and eventually accepted and merged. So that's a place for me to dig in. And I want to make sure that I'm not paying extra for the GenAI speed in writing code and then very long reviews. And PR size is another great example. We all know that small PRs can get reviewed better, faster, deployed with less risk, and they're a great leading indicator of like a well-tuned delivery machine. But it's so easy to create so much code with GenAI. Like Copilot, you hit tab, you get 50 lines of code. So if your pull request size is like bursting up when you're using GenAI, that will create a problem down the road, down your pipeline. So by being able to track it, now you can start to control it and understand the goal is not to just create more code. The goal is to create code that can be actually reviewed and ingested into the code base with low risk. To summarize, GenAI rapidly being adopted. Everyone is using Copilot. I think that's basically the takeaway. And it's already there. It's already becoming mainstream. It's no longer a question of if or even when. And this is already having major impact on how we deliver software. Remember those stupid bots, the 13% of PRs? There's already a big chunk of work in the review pipeline, in the pipeline to get code delivered, that is not created by human, and it's becoming much larger with broad GenAI adoption. Organizations need to start preparing today by having measurements in place so that I can track how these tools are being adopted, how they're impacting my delivery, how they're helping me write code faster, maybe write better code, more documentation, and so on, but also measure and understand the risk. Is it causing my PRs to be huge? Is it giving me, creating a backlog of reviews, longer reviews, longer cycle time, and so on? These are all risks that I can manage. And if there's maybe one takeaway that you should be thinking about, solutions that do not include automation will never scale. You're thinking about a 10x influx of code. Just changing a little how you work is not going to scale to meet that demand. So any solution that wants to say, yes, I can ingest that, all this new code at great speed, I can make this happen, has to think about automation at the heart of how we review code, how we get code merged, and of course, eventually built, tested, and deployed. So thank you. We invite you to get our free engineering benchmarks report. And if you want to learn about automating the merge phase of your PRs, take a look at Goodstream. It's all there.